Okay, yes. So I think till now, Salman, you only have joined. So I just want to do the solutions and practice the solutions of the question. Then I'll free you. So first question was, two circular metal plates, each of radius 10 centimeters, are kept parallel to each other at a distance of 1 millimeter. What kind of capacitor do they make? And you have to mention one application of it. See, two plates, if they are kept parallel in front of each other, it will form a parallel plate capacitor, right? And application can be a capacitor is used in oscillatory circuit. Remember, I made you study LH oscillation, LC oscillations, which were not coming in your exam, but one
Yeah.
of them, it was the application where magnetic energy was fixed. We did it because just it was the application of capacitor. So here a parallel plate capacitor will be constructed and application will be oscillatory circuit. Second question which I had given was, if the radius of each plates is increased by a factor of √2 and their distance of separation decreased to half of its initial value, you had to calculate ratio of capacitance in both the circuits. See, I'll write down this separately. Here for the second question, capacitance is epsilon naught A by D. So if you even write the area, that becomes epsilon naught pi r square by D. Now, new capacitance is, whatever is the new capacitance, difference will be in radius. Radius is r√2 divided by d by 2. Fine. So this will become 4c. If you take the ratio, that will become 1 by 4. C by C prime will become 1 by 4. Fine. That was what was the second question. Then the last one was, suggest one possible method by which capacitance in the second case be increased by n times. See, how can you increase the capacitance? If you insert a dielectric constant n, then capacitance will become n times, right? That's how we write C is equal to NC. C prime is equal to NC. So that's how you can write for the second possible case. Or if you decrease the distance, capacitance is inversely proportional to distance. Okay, see, yes. So you had to suggest one possible method by which capacitance could be increased. So if you decrease the distance, that is C is inversely proportional to D. So if you decrease distance, capacitance will again increase. So these are the method. Or if you even increase the area of the plates, the capacitance will increase. Second question was, 4 particles. These are kept at the charges of a square on the vertices of a regular pentagon. So C class, regular pentagon is there. So 5 charges are not there, rather 4 charges are there. So this is also a very easy question which I had given. Most of you have done this correctly. So see, these are the 4 charges. You have to determine electric field at the center. See class, if it is balanced, if it is in equilibrium, it means whatever is the electric field by all of the 4 charges, this is exactly equal to the electric field by the 5th one that was missing. Then only we can say at the center this is 0. So if there was a 5th charge, then this would have been 0. It means this all these 4 charges are producing exactly negative of the electric field if a single charge would have been kept on the vertex. So electric field will be simply kq square by r square. Center is okay, this is a, so that will become kq. This will become kq by a square, not kq square by r square. That will become kq by a square. And direction also you have to find out. So direction will be towards this. Whatever you name this, let's say this is A, B, C, D, E. So, and this is O, so that will be along OE. Fine. Next question was, you were given a series of resistors were given. You had to calculate the current through 4 ohm resistor. So 4 ohm is only one, right? Ye wala hai na, 4 ohm. See here, equivalent resistance if you find out between till here. So 2 plus 4 plus 2, that will become, here you have 8, 8 and 8 will again become 4. See, I'll tell you. Let me redraw the circuit here separately. This was 3 ohm. This was 2 ohm. 3, 2, 2. This is 2 ohm. This is 2 ohm. This is also 2 ohm. Here we have 4 ohm. This is 8 ohm. And this is also 8 ohm. This is 9. C class. We'll start with here. This is in series, so this becomes 8. It's like 8 is connected. When you have 8, so 8 into 8 divided by 8 plus 8, that will be 4 ohm. Right, so it means till here you have 4 ohms. Then again this will become, see here, this will become 2, 4 and 2. All these part will become 2, 4, 2. Same thing, you will get 4 ohm back here. Right, so 4 plus 3 plus 2, equivalent resistance of the circuit is 3 plus 4 plus 2, that is equal to 9 ohms. So current is 9 by 9, that is 1 ampere. So this is 1 ampere through all of these, right? So current, now it will be half of it till here, half will be till here, then half will be till here, and then 1/4 will remain here. So directly you can take 1/4. For this resistor, it will become 1/4, or you can write 0.25 amperes simply. This is how we have to find it. What else were the questions that were given? This is done. Then next question is that show that the magnetic field along the axis. See here, how do we have to solve this question? Firstly, you will write the magnetic field that is, this is for the third question. For the third question, see, magnetic field at the center. Magnetic field at the center will be mu naught Ni by 2r. And magnetic field at the axial, at the center means at the center of the circle you're calculating. But if you drop an axis along the center of a circle, that is known as the axis of the circle. So axially magnetic field is written as mu naught Ni(r) square divided by 2r square plus x square to the power 3 by 2. This is all you have. Now if you take up the ratio, This ratio you have to take. BC by BA. So mu naught Ni, mu naught Ni. 2, at least this part will get cancelled. So you will be left with R cube by R square plus X square to the power 3 by 2. Right, R cube by R square plus X square to the power 3 by 2. This is what you are left with. So let's take R cube common. That will become 1 plus X square by R square to the power minus 3 by 2. This 3 by 2, it will go up. So now if you will apply binomials, this will become 1 minus 3 by 2 x square divided by r square. Simple binomial expression you will use 1 plus x to the xn. 1 plus xn, x to the power n is equal to 1 plus xn. Simply that binomial expression we have used over here. So 1 minus 3 by 2 x square by r square is left till here. Now see class. Fractional decrease when you have to calculate. Fractional decrease is B center minus B axial. This is exactly the change that has come. And what is the original? This is B center. So this becomes 1 minus 3x square by 2r cube 2r square. So 1 minus 1 becomes 0. You only have 3 by 2. And minus into minus will become plus. So x square by r square. This you had to prove. What was the next question then? Electron in an atom. This says electron in an atom revolves around the nucleus in an orbit of radius 0.53 angstrom. You have to calculate equivalent magnetic moment if the frequency of the revolution of electron is 6.8 into 10 to the power 9 megahertz. Okay, see class, this is just one line. I'll discuss it here only. Magnetic moment, this is actually equal to I into area, and current here, frequency is given. Current is simply charge, electronic charge multiplied by frequency multiplied by area. That's how you have to use. Any doubts in this question? Simply you will use this equation, you will get your answer. This also, everyone has done this part also correctly, the magnetic moment question. Here you are given with the magnetic flux. So you have to differentiate this. See, 5t square, this will become 10t plus 6. So if you put 1 here, you get 16. 16 millivolt will be the answer. Right, this will be 16 millivolt because here I have not mentioned, this is milli Weber only. This question says that two bulbs B1 and B2 are connected in series with AC source of EMF 200 volt. Labels on the bulbs read 200 volt and 60 watt for the first bulb and 200 volt, 100 watt for the second bulb. You have to find out the ratio of their resistance. See, this also I'll do it separately and show. Ratio of resistance, power and potential difference. No. See here, R1 will be equal to V square divided by P1. R2 will be equal to V square divided by P2. So R1 by R2, this is equal to P2 divided by P1. So this is equal to 100 divided by 60. That will become 5 by 3 and the ratio will become 5:3. Now in a series circuit, current will always remain the same. So if for the second part, this is the first part. For the second part, P1 is equal to I square R1. P2 is equal to I square R2. Again, when you will take the ratio, now you have the ratio of the resistances with you. You have to find out P1 by P2. That will simply be R1 by R2. Since current is remaining the same, you'll get the same answer, 5 by 3. Because here current remains the same. Last is, the last was what? Potential difference across the bulb. No. So see, potential difference across bulb 1. V1 will be IR1. V2 is IR2. So class, see here again. Here what will happen? V1 by V2, when you will write IR1 by IR2 is equal to R1 by R2, which is again 5 by 3. So for all the parts, you had the answer as 5 by 3 only. I think one more question was there. See, yeah, the electron in the hydrogen atom is moving with a speed of 2.3 into 10 to the power 6 meter per second. This is the speed that is given in an orbit. What is the radius? 0.53 angstrom. You have to calculate the magnetic moment of the revolving electron. See class, for this you have a specific formula already stated. Magnetic moment for the orbit, or magnetic moment for an electron which is revolving around an orbit. This is exactly equal to the electronic charge which is present multiplied by the speed multiplied by the radius divided by 2. Directly use this formula. Here, see, 1.6 into 10 to the power minus 19. Velocity is 2.3 into 10 to the power 6. Radius is 0.53 into 10 to the power minus 9 divided by 2. You will get your answer this as 9.75 into 10 to the power minus 24. Most of you have left this question. Just use this formula, magnetic moment of the revolving electron. So this was all about your paper discussion. I wanted to do it today. Tell me, all the questions are clear? Any doubts in the question when which you had attempted, or any solution you want me to write, any solution you want me to repeat, or you want to note it down? Is this clear to all of you? Now, one last test I will take, your last class. When do we have? We have the class on Monday directly now, class. So second book, this was the test from the first book, right? So from the second book entirely, I'll take your test. Yes, Sarah, I'll explain. Just a second, Sarah. So second, it would be your second book, entirely your second book's test. So same way, one day I'll have the class, one day we'll just take it up, your doubts and all. Then entire Feb, you are left with the doubt session. Whatever doubts you're having, doubts can be cleared. Fine. Question number 3 is what? Okay, this circuit. No, fine. See here, Sarah. This is 2 ohms. This is 4 ohm. This is 2 ohm. These three resistors are there. All these 3 resistors are connected in series. So these 4 plus 2 plus 2, this becomes 8. Right? This is 8 ohms, right? This is 8 ohm. So it means I can replace this. Look here. Instead of 8, see, this is now 8 ohms. Fine. Now 8 ohm resistor and 8 ohm resistor, these are connected in parallel, Sarah, right? Both these are connected in parallel. So both, when the resistors are identical, you have to divide it by 2 directly without using the proper formula. So this 8 and 8, this will become 8 by 2. Simply you write this becomes 4 ohm. Let me make it 4 ohm first. So now this is 4 ohm. Now I'm reducing it back. 4 ohm, 2 ohm and 2 ohm. All these are connected in series. So 4 plus 2 plus 2, that gives 8 ohm. Again, I have 8 ohm. Now look, again this has become 8 ohm. So 8 ohm, these are again connected in parallel. That will give 4 ohm. See, now these are left, we are left with these connection in series. So 4 plus 3 plus 2, that will become 9 ohm. Now you have to find out current. Current becomes 9 divided by 9. That is 1 ampere. Is it correct now? Is it clear now, Sarah? All right, class. So I'll stop here. Now, entire February, you will be having revision open doubt classes. Whoever is having doubt, either you can text me on WhatsApp also. You all have my number on the group you can send, or directly personally also in my number you can send me. Otherwise, now you have one last test that is remaining from my side, the class test. Otherwise, your rest of the mock tests will keep on going. I think 7 tests have already occurred. No, so it's going to be the 8th mock test. Right, 8th mock test. So you can leave now. Let's meet on Monday with the preparation of second. Any doubts you can have. Okay. Thank you so much, class. Thank you so much.